Hello, you're welcome to my channel. Now here we want to integrate cosine of full power of x over the x variable. Now we're going to do this using some trick substitution initially, then we go on with our normal way of integration. Okay, so here I'm going to do the trick substitution like I told you. I'm going to first of all rewrite this as integral of cosine of square x, and I square that. Okay, dx. So just splitting it into two powers, power 2 and power 2. That's still going to compute back to the original question or to the original integrand. Okay, so from here, well, the trick substitution goes that cosine of square x, okay, is the same thing as saying the half of cosine of, let's say, 2x and then plus 1, right? If you're having cosine of 2x, it's going to be the same thing as cosine square x minus sine square x. Then if you just do some computations, this is what you're going to get back, right? So in place of cosine of square x, I'm just going to plug in this right there and I'll raise it to power 2, like this. This is going to become integral of, so I'll just have 1 over 2, then cosine of 2x plus 1, then I now raise everybody to power 2. These two here, these two, so this is just it. Right? Okay, so now put down the dx. So we've just made a substitution to make our work a little bit easier so that we'll be able to have the antiderivative we're looking for. Okay, so from here I'm just going to share the square, the power to all of them. So I'm going to have integral of 1 over 4, then in the bracket, let me just take it bit by bit. So we're going to have this, okay, and then plus 1, and I still square that. And I still put down the dx. Well, from here, since this is just a constant multiple, 1 over 4, I can take it to the form of the integral sign. I'm going to have 1 over 4, then the integral of, I'm going to do some expansion of this, and I'm going to have cosine of square of 2x plus 2 cosine of 2x, then plus 1. This is just some binomial expansion of the second power. Okay, that seems right. That is it. So, I'm just going to, integrate each of these. That's just like saying I'm going to split the integral sign because I'm just having sum here of functions. So this will now take us to, well, let me just split this 1 over 4 for all of them. That'll be 1 over 4 integral of cosine of square 2x, square of 2x dx, then plus 1 over 4, then the integral of 2 cosine of 2x, okay, dx, then plus the integral of 1 dx, like this, alright? Okay, so we just have 1 over 4 of each of them. Sorry, this is 1 over 4. I'm just splitting it throughout. I have for this one, and I'm also having it for 2 cosine of 2x. Then also have it for the 1. Okay, and then remember to put down the dx for each of them. So we can integrate this. This is just 1 over 4. Then the integral of 1 over the x variable is just x. And here we can just have 2 over 4. That is just more like 1 over 2. And then cosine of 2x, the integral of that. Now, the integral of cosine of a constant before the variable x, cosine of 2x, is just going to give you sine. The integral of that is going to give you sine of 2x divided by 2. So the constant will come to the denominator, just like differentiation, where the constant will be a constant multiple, okay, after differentiating. So here it will become the denominator, like sine of 2x. So you integrate the whole thing, you have the sine, and you divide it by this constant here, so you just have the 2. Okay, don't forget that this 2 was multiplied with 1, so we had 2 over 4, which is the same thing as 1 over 2. Okay, so the only little problem here I'm having here is to integrate the whole of that. 1 over 4 of, so we need to know what is the integral of cosine of square 2x dx. So I'm going to solve that down here. I'm going to have that the integral of cosine of square of 2x dx. Well, we will get back to the substitution we just did at this point. When we were squaring the cosine of x, we were having 1 over 2 cosine of 2x. Now that it's 2x already, we just have 1 over 2, then cosine of 4x, then plus 1, like this, alright? So from here we can just put this back. We're going to have 1 over 2, then the integral of cosine of 4x, then plus 1, and just put down the dx. I know by doing this, by integrating this, we're going to have 1 over 2, then cosine of 4x is going to give us the integral of cosine 4x, is going to give us sine of 4x over 4, then plus x, and like this, we are just there. So the whole of this, we're going to plug it in right here, and we're going to have 1 over 4 times 1 over 2 times sine of 4x over 4, then plus x. So I'm just going to manage a little space plus x, then I add it. And now I'm going to go ahead and multiply this bracket, everything in here. So I'm going to have, first of all, 1 over 2 times sine of 4x over 4. So you're going to have sine of 4x over 8, and I add it with x over 2. No, I still have this other one out here to multiply. So if I multiply everybody by 4 in the denominator, this place is going to turn to 32. So let me just multiply it once. I have here to be 32, 4 times 2 is going to be 8, then 8 times 4 is just 32, and again, 4 times 2 is going to be 8, so 8 times 1 in the denominator is just giving us 8, and I can add it with, well, 1 over 2 of sine of 2x over 2, and again, plus 1 over 4 times x. Well, here is just x, and here is just x, so we can take them together. And again, we can also take these ones together, so this will become sine of 4x over 32 plus these 2 and these 2 will multiply, so we just enter with sine of 2x over 4. And again, we need to do some additions here. We have 1 over 8x plus 1 over 4x. So what I can do here is that I just add these two fractions. So before doing that, I need to get a common denominator. So 8 and 4, I can see 8 to enter to work for the both of them. So if I multiply this one by 8 and also multiply this right here by 8, I'll see that this and this will cancel. Just enter with 8. Now after multiplying, I need to divide everything by 8. So that will just become x. 8 times 8, that's 1, that is x, plus this is just going to be 2x divided by 8. So this will just be 3x over 8. Okay, so from here we are done. So we just need to add a plus c, and this is the antiderivative of the given function.